Hi, I am Ss7. Always I wondered how telecom works, how a call is connected, how a communication is created between two nodes, or two mobile devices. I really wanted to learn about that. But, whenever I start reading this, pages and pages of documents made me feel like sick. So after all the research, I thought animated way of learning is easier and clear to understand. I created this video which explains about Ss7 signaling fundamentals, which is the heart of communications and telecom networks. How signaling was made at early days and now. Early days signaling could be imagined with trunk call booking. And now due to the huge number of users and digital signals, signaling networks become complex. Let's know about the interface medium first. We have mainly three different medium of transport. E1, T1, Ethernet. T1 is a digital carrier signal that transmits the DS1 signal. It is a data rate of about 1.544 megabits per second. It contains 24 digital channels. E1 is similar to the T1. T1 is the North American term, whereas the E1 is the European term for the transmission. The data rate of E1 is about 2 megabits per second. It has 32 channels at the speed of 64 kilobit per second. It is important to know that 2 channels among the 32 are already reserved. One channel is used for signaling while the other channel is used for controlling. Fast Ethernet is one of the options for any speed above E1. There are 2 essential components to all telephone calls. The first, and most obvious, is the actual content, our voices, faxes, modem data, etc. The second is the information that instructs telephone exchanges to establish connections and route the content to an appropriate destination called signaling. Ss7 or signaling system number 7 is simply another set of protocols that describe a means of communication between telephone switchers and public telephone networks. Ss7 is always compared with OC model for better understanding. Layer by layer is linked to Ss7. Ss7 is MTP1, MTP2, MTP3, SCCP, TCAP, ISUP and application layer protocol is its stack. MTP1 performs the physical layer function, electrical impulse to data terminations. MTP2 performs the data link layer function, link error detection and correction by retransmission, error monitoring and reporting, etc. It uses 3 types of signaling units: LSSU, MSU, FISU. FISU and LSSU are used only for MTP2 functions. MSUs also contain the same MTP2 fields, but they have 2 additional fields filled with information from MTP3 and level 4 users that contain the real signaling content in form of SIF and SIO. LSSU indicates the link status and indicates a signaling point status to the remote signaling point. FISU are sent when there are no LSSU or MSS to be sent. A cyclic redundancy check, CRC, checksum is calculated for each FISU, allows faulty links to be identified quickly and taken out of service. MTP3 performs the network management and routing. It uses PC, point codes as OPC and DPC for routing. Each node is uniquely identified by a point code. The MTP3 portion of an Ss7 message consists of 2 fields, the signaling information field and the service information octet. The SIF contains routing information and the actual payload data being transported by the MTP3 service. The CO contains general message characteristics for identifying the network type, delivering them to the appropriate MTP3 user. Message handling is done by discrimination and routing based on PCs. Network management is divided into 3 processes. MTP3 decides on which link to use and which not to use is based on these. The ISDN user part is responsible for setting up and releasing trunks used for inter-exchange calls. As its name implies, ISIP was created to provide core network signaling that is compatible with ISDN access signaling. The signaling connection control part sits on top of message transfer part 3. In the Ss7 protocol stack, the SCCP provides additional network layer functions to provide transfer of non-circuit related. Technically, SCCP can also transfer circuit-related signaling information. However, this is an exception. SCCP provides functions with connection and connectionless services. Main function of SCCP is global title translation and enabling MSU to carry non-call related messages. A global title is an address, such as dialed digits, which does not explicitly contain information that would allow routing in the Ss7 net. As such, the GT address must be translated into an SS7 network address DPC plus SSN. TCAP provides a generic interface between services that is based on the concept of components. Components comprise the instructions that service applications exchange at different nodes. Mainly functions like session layer. TCAP holds a session with the TCAP ID until the transaction is complete or discarded. In-app, map, CAP are application layer protocols deployed over the TCAP layer. Each application layer protocol functions its own task, like interacting with DP for balance detection of prepaid services, and many features makes use of the lower-level protocols. Due to increasing demand and migrating to IP technology, now SS7 is migrating to SS7 over IP technology called Ss7. It makes use of same function as SS7 with user adaptation in SCTP. Thank you for watching.
Created using Powtoon.